Okay, for the following list of equipment, check the items you use for the purpose of determining a slit width D. So you could use a laser pointer, you could use a metric ruler, or a meter stick, whatever.
Meter stick. Isn't it that
Whatever, who cares?
More in guidelines.
they got both.
That should be it, right? So we just put the laser pointer here, the light comes here,
We need a screen.
and then, oh, okay, yeah. If you said on the wall or something, it would be fine. But okay, so let's put a screen, and then we're gonna get like some.
Oh yeah, because then isn't when you shine light and like in the simulator, there's this strip of really bright and a strip of not really bright when it goes
Yeah, you want to make sure that you're not confusing it with the umbra and penumbra that comes from a regular light source as it goes around some other object or as the light goes through. Because if you just put if I take a board or a piece of cardboard and I cut a hole in it big enough that I can see through it normally, that's too big of a slit. In order for diffraction to occur, the wavelength has to be on the order of magnitude of the aperture. So when you cut something big that you could see through with your eye, then the light that comes through, anything around it, that isn't usually aberration, that's not diffraction, that's just reflection coming in at different angles. You get what I mean? Yeah. So in order for a diffraction grating or a single slit to work, this slit, usually you have to, you can take a piece of aluminum foil, and then you take a really, really clean, fresh, sharp razor blade, slit it, and then put your finger so that it's perfectly smooth, and you can barely see the slit. That's how thin the slit is. Okay. So the lamp and the prism. Oh, for an alternate. Maybe you could use the lamp, then you would put the prism in front of the lamp to get diffraction, the rainbow, and then you move the prism until you get a specific wavelength on the thing. All right. But in order for this to work, we have to know lambda with some certainty.
And there's no need to repeat, so people can
Yeah.
You get the point if you do that. Or
Which one?
If you repeat, if you.
Okay, well, you know what? I'll tell you what we'll do. We'll just kind of zip through this, just generally talk, and then we'll go look at the solution, and then we'll kind of pick that through. So sketch a diagram of the experimental setup. There you go. This is important, okay? I cannot tell you how many people I have dinged for not following the directions. Okay, when it says label the pieces, you have to say screen, laser pointer, ruler, or whatever, meter stick. And yes, there are people who are big enough jerks that if you put ruler, they will not give you the point. Because you didn't have a ruler, you had a meter stick. Seriously, there were people like that, so make sure you're careful about that. Then outline the experimental procedure you would use, including a list of quantities that you would measure. So obviously, we all know we're just going to measure D, right? We're going to put this laser pointer through there and then adjust the length until we get an image on this. Yeah.
But wouldn't the D conflict with the D we're trying to measure?
Or whatever. L. Sorry. I just went to D as distance in my head. Let's say L. I think in the equation that's L. Yeah.
L for length.
Good point, Max. And then explain how you calculate the slit width D, and then you just have the equation, right, from the formula. And suppose the separation D between the strips increased, but everything else is kept the same. What changes would you expect to observe? Explain your reasoning. Just look at the equation. The equation is, what is it? X M is equal to M lambda L over D. Yeah. So if I increase So like, oh yeah, so I'm gonna measure L, and then I'm also gonna measure this, right? XM, that's XM, right? And if you pick the first one from here to, from here to here, then that's an M of 1, right?
Oh, they're basically just using the.
We're just using this equation, boom,
Oh.
and just solve this for D, right? So you just set this up, pick this length, whatever you want, 2 meters, something like that. I mean, you would futz with it in real life to get a nice bright pattern, so that you can measure it, right? You would just arbitrarily pick the distance and leave it there. Like you'd say, I pick a distance, let's say for example, 2 meters, and then I would put it there, and then I would try to measure. And then once I've measured that, then I can, okay, how are we doing? Questions? So then, of course, the issue here is, if D is bigger, what happens to XM? Smaller, right? And if D gets too big, then XM becomes 0, right? Which means, if this is too big, light just passes through, there's no diffraction off the edges. As D gets bigger, right, then this distance gets smaller. And based on the wavelength, there's a value that as this gets to a certain length, all that'll happen is light will just come straight through. XM is the distance from the middle bright line spectrum to the first kind of band, first bright band. Yes? Okay. Haha, 2 questions with 1 8.
Wait. So you just did C and D.
Yep. And then, yeah, and then we just did E2.
So 3 questions with 1 equation.
Okay, so I'm not just stopping there. What we're going to do is take a look at the answer key. Is that 2011?
Yeah. Well, I don't know why I'm trying to do that.
I know. Why does everybody want to be Japanese? What is Japanese?
Yeah,
Yeah, why is Japanese awesome? I don't get it. I mean, how are they not just like everybody else on the planet? Okay, so here we go. So if we take a look at the breakdown of points, select the measuring device and select the light source. That's it. So you didn't even have to do the screen. I mean, it was a good suggestion, Kev, so that's good.
Well, but if we put screen on, will you still get the points?
That's fine. Yeah, you're good. You
Yeah,
just
see, but
have to have those 2 things. Okay, then for 2 points, it's basic setup, which I did. Then 4 points for C.
Do we get points for
That you have to show that you're shining a laser through the slit, that you measured L, and that you measure XM, or the length between bands.
because you're using the screen, right?
Yeah. Well, it doesn't matter, screen, whatever.
On the screen.
And then for D, it's just using that equation. And for E, it's just stating what the equation states, which is that it's the inverse of D. As D gets bigger, XM goes away, and it stops working. The distance between the bands gets thin. And once that bands are indistinguishable, you can't use it to measure anything. Questions?
Fire and laser. You just have